Hello, this is IBM data replication to the Iceberg target engine. We'll be looking at a Hadoop catalog that's local to our box and a local file system. This is a great opportunity to try out Iceberg without an investment in more than your file system and having one available where your target engine is installed. First, we look at the catalog properties. We see them defined here. And we see the Iceberg file system properties. The file system is a local file system, and the catalog is one that actually just sits with its metadata on the local disk as well, in the location shown. Next, we wanted to show that there's currently what the table definition looks like and the catalogs. Downloading Spark SQL gives you the ability, all the Hadoop libraries needed, to be able to create the Hadoop catalog metadata information. We're showing the two catalogs we have available here, and we're showing some of the tables we've predefined. You can see the create table statement above. The Spark SQL utility is downloadable. It's an open source project. Defining with Spark SQL the table's definition, we can see the various columns, and these will be the columns that are essentially our Iceberg table, define our Iceberg table. We're showing now that there's no actual content in these table at the time. We're going to put some data in there. The other thing we want to show before we switch to doing the mapping is that the current directory we previously set as a location for our Parquet files has no content. So there are no Parquet files currently for the Iceberg table defined in that table's location. When looking at the Iceberg target, you can set properties that define which type of catalog and which type of file system you're using. These are defined at the instance level in the data store properties. Here we can see we've told the IDR Iceberg target that it will be using a Hadoop catalog to instantiate one of those, and a Hadoop file system, and a local file system, which is where the data files, the Parquet data files, will reside. Next, we need to map the table. So we are going to be using a DB2 source, and Dimitri, who's doing the video, will be selecting one of his source tables, users. He'll now map it. And what we're doing here at this point is we're using that Hadoop catalog to query it and see the example table that we'd previously shown the definition of. Completing this mapping, we'll see that the DB2 source columns are lined up with the columns in Iceberg, and he'll show the table mapping details here. This type of mapping is a mirrored mapping, so we're going to be applying the actual changes. When deletes are performed, the rows will actually be removed from the resulting table. First, we're going to start mirroring, and that will add the content that already existed in the DB2 table and move it across to the Iceberg table that is on our local disk. We select from our table, and we see now that the initial rows that were in the DB2 table are now present in the Iceberg table. We're using Spark SQL to be able to query the metadata files that are of the Hadoop catalog. Next, we'll insert a row while the replication is running and see that those changes put into DB2 are reflected on the target. And sure enough, we have them there. We're going to perform an update and a delete as well eventually, and we'll see those changes reflected. We can see that when we do the update, the actual change returned by Spark SQL has actually taken the various changes and given the net result of those changes. Now we're going to delete one of our rows and see that when we use Spark SQL to query, we indeed see the row deleted. So this is basically having an Iceberg table from open source components sitting on a file system locally to where we've installed the IDR Iceberg target. It's great for trying things out, and it's extremely flexible. You can get started right away with this. Next, you see the Parquet files that all existed as well.